All right, adding and subtracting fractions. So, the reason we did multiplying and dividing them first is because those are actually easier than adding and subtracting the fractions. When we add and subtract fractions, we need to always make sure that the denominator in all of the fractions, no matter what question we're in, is the same. So we have to find a common denominator. So in the very first one, we have a 6 and an 8. Does anyone know a common multiple of those two numbers? 24, that's right. We can turn both of them into 24. How would I turn 6 into 24? What would I multiply by? 4. And whatever I do to the bottom, I have to do the what? Okay. And what about 8? Okay. So, our new question is going to ask us what? 12 over? Yeah.
12 over 24.
All right. All right. So when we add them, the denominator stays the same. Nothing changes. We only add or subtract the top values, the numerators. So 12 and 12 is 24. What does that equal?
1 whole.
1 whole. That's it. All right. Same numbers over here. So we know we have to multiply to get the same common denominators. Actually, let's multiply by a different one. Let's find a different denominator and see if we get a different answer. What would be another common denominator other than 24? 32? Okay. Does 6 go to 32? No. 48 works. 6 times what gives us 48? All right. And 8 times what gives us 48? There you go. So, if you're unable to find a common denominator off the top of your head, one way to find one would be to take the denominator of the other number, multiply it by the first, and vice versa. Take the denominator of the first number and multiply it by the other. If you do this pattern, you'll always get a common denominator. It won't always be the lowest one. You might have to reduce after, but it will give you a common denominator. So you just multiply the two denominators by each other, and you'll get the same number. What number do we get underneath? 48. What will be on top here? Subtract. And what about here?
48.
So, 0 over 48. Essentially, what were both these questions asking? 1/2 plus, yeah, and then 1/2 subtract 1/2. So that makes sense. We got a whole and we got nothing.
So it's pretty much the same operation for you.
Okay, so in our next one here, we have a whole number and a fraction. So, in order to add and subtract fractions, it's far easier if we put everything into a fraction form. How can I turn 5 into a fraction? 5 over 1, okay. Now when I put it over 1, does it have a common denominator right now?
No.
How do we get a common denominator? That's right. So what are our new values? 10 over 2 plus? Excellent. Very good, Vernon. 17 over 2. Denominator stays the same, and we just add the top numbers. Okay, the last one. Okay. I got 3 terms here. I could find a common denominator between all 3, which can sometimes be difficult. Or I could do it in pairs and work with 2 at a time. Okay? Since, according to BEDMAS, what would we deal with first? We go left to right because adding and subtracting are considered the same. So let's just work on this as one set of pairs. What's 5 plus 3 over 6? We got to turn 5 into a, okay? And then multiply by, good. So what's the new question say? 30 over 6 plus 3 over 6 minus 7 over 2. Okay? So let's work with this first pairing here. What is 30 over 6 plus 3 over 6 going to be? 33 over 6. Subtract 7 over 2. Now what do we need to do? That's right. We're going to have to multiply this fraction by 3. Or, as Martino said, we can divide this fraction by 3. So let's do that in both. We're going to do 2 different ones and see if we end up at the same answer. So to the right, we'll have multiplied by 3. We'll end up with 33 over 6 minus 21 over 6. And then to the left, do it in red. 33 divided by 3 is 11, and 6 divided by 3 is 2, minus 7 over 2. What are our 2 answers here? What's 33 subtract 21? That's right, 12 over 6, which is how much? And in this one, what is 11 subtract 7? 4 over 2, which is? Exactly. So no matter which way we did it, we ended up at the exact same answer.